Hello, this is Mrs. Ringrose, and we are moving along on our solving skills. Today we're going to be doing more than one step in order to solve a linear equation. We're going to have to do something with addition or subtraction, then multiplication or division. So before we do that, I want to review with order of operations. If you had something like this problem right here, we would ask you to do the multiplication first and then the addition. Or even if this was written backwards, you might have something like this. We still do the multiplication first and then we do the addition because we have a specific order that we have to do math in. So when we solve and we're doing inverse operations, we want to undo, we want to work backwards. So if we were going to do the multiplication first before, we're going to do the addition first, or more accurately, we're going to undo the addition first. So here's our first example. We read this as 3 times a number plus 5 should give us 17. So again, working backwards with order of operations, the first thing I want to do is take care of that adding of 3. So I'm going to adding of 5. So I'm going to subtract 5 from both sides. And again, I want to make sure I'm doing that to both sides. And again, we're using our addition additive inverse, so those are going to cancel out. And I'm going to bring down 3 x's this time. And on the other side, I have to simplify, and I get 3x equals 12. So again, all I did on that side was simplify. Next, I need to decide what it is I need to do to get rid of the 3. This is read as 3 times a number. The operation that's going to cancel out that 3 times x is going to be if we divide it. So I'm going to divide both sides by 3, and then I get x equals 4. And then finally, you know how much I want you guys to check your work. We're going to go ahead and take the original equation, 3x plus 5 equals 17, and I'm going to take this value we found for x and see if it works. So does 3 times 4 plus 5 give me 17? 3 times 4 is 12, plus 5 is 17. So yes, I have checked it. Okay, so on to another couple of examples. Again, because this is a video, feel free to pause or watch it again. And definitely ask questions of me or Mrs. Lang when you see us next time. So here's another example. Negative 5x plus 6 equals 10. So the first thing I'm going to do is get rid of that 6 by subtracting. So I'm going to rewrite it like this. Again, I've got that negative 6 on both sides, because whatever I do to one side of the equation, I have to do to the other side. 6 minus 6 cancels out to 0. So I'm going to bring down a negative 5x, because that's what's left. And on the other side, 10 minus 6 is going to be 4. All right. Now I have to decide what I want to do to get the x alone. This is negative 5 times x. So I'm going to divide both sides by negative 5. Remember, when we're dividing, we want to divide by the same sign so that the negatives can cancel out. So I get that x is equal to negative 4 over 5. Or if you like a decimal, that should be negative 0.8. So finally, I want to just check my work to make sure this goes back into the equation and satisfies it. So does negative 5 times negative 0.8 plus 6, is that going to give me 10? All right, so I multiply this together, I get a positive 4. And positive 4 plus 6 does equal 10, so this was checked. Okay, so I did get the right answer. All right, moving right along. Sometimes you're going to have an example where the variable is on the other side of the equation. but you're going to be asking yourself the same questions. What is happening to the x and how do I undo it? So working backwards with order of operations, the first thing I want to do is get rid of that minus 12. I'm going to add 12 to both sides. All right. When I add 12 to both sides, on this side we canceled out so that I only have a 6x. And on the other side, if I combine like terms, I get 27. And now I need to get rid of the 6. So this is 6 times x. The opposite of multiplying is division. So I'm going to divide both sides by 6. And I get 27 over 6 equals x. I can reduce that even further by putting a 3 into 27, getting 9, and a 3 into the 6 and getting 2. And then I really recommend that you go back and you check this by putting this back in. And if you don't like the fraction, you can always make this a decimal. All right, just have one more crazy thing I want to show you. So if you look at the next two problems, they kind of look similar. One has that x plus 2, all that being divided by 5 equals x equals 8. And then the one below it says that if we take a number and we divide that by 5 and we add 2, it equals 8. These are actually different equations and you are going to solve them differently. The first one, if you want to think of it as parentheses, when we have a long division bar like that, you do the x plus 2 first. It's a grouping in and of itself. That kind of helps drive the, well, if I'm using order of operations thing, what do I do? So in this case, the first thing you want to do is get rid of the fraction. So that's all being divided by 5. So the first thing we're going to do is we're going to multiply by 5. So I put 5 times on both sides. You cancel out, and you get x plus 2 equals 40. And then I can use an additive inverse property by subtracting 2 on both sides. To cancel out that 2. These cancel out, and I'm left with x equals 38. All right, so let's check to make sure it's right. If I put 38 plus 2 and divide all of that by 5, will I get 8? Well, again, this is a grouping symbol. 38 plus 2 is 40. 40 divided by 5 is 8. So I checked it. Down at the bottom, it looks a little different. The 2 is not being divided by 5, only the x is. So in this case, the first thing you want to do is get rid of the plus 2. So this is going to look like x over 5 plus 2 minus 2 equals 8 minus 2. So again, I'm doing this because in the first example, everything was being divided by 5, so I wanted to undo that. In this example, we're adding 2. We got to take that away first. All right, so after we subtract 2, we have x over 5 equals 6. All right, so we simplified. And now this looks like something you can do because just the x is being divided by 5, and I'm going to undo that by multiplying both sides by 5. That cancels out, and I'm left with x equals 30. Okay, and that's it for today. I hope this helped you understand it or get started on how to handle two-step equations. Sorry about that, if you're still writing that down. And again, I'll give you time in class to ask some questions, and we'll all become masters at this. And have a great day.